start thinking of a high-density polyethylene pipe being put in the pipe burst, it's snaking and being pushed around and belted around and hit by excavators and pushed down into the pit and then snaked in and bursting apart the existing PVC pipe. I mean, you can't really do that with any other kind of product.
Welcome to another edition of the PE Alliance's podcast program, where today we're interviewing David O'Sullivan, a Canadian. Well, actually, he's not Canadian. You're from Ireland, aren't you?
Correct.
Yeah. So excited to talk to you today. But first, Dan Landy, please introduce yourself.
Yeah, what context clue gave it away that he was Irish? But thank you, Mr. O'Sullivan, for being here today. Good to hear everybody. Really excited for today. We haven't had a contractor on in quite some time, so we really like to focus on the design and the technical parts of the pipe. But it's kind of a treat to have someone in the trenches on the podcast today.
That's for sure. But Dan, tell us who you are and what do you do?
Yeah, Dan Landy. Handle the engineering services at the Alliance. So if you have projects you're working on, reach out. We can point you in the right direction. A lot of that's just general inquiries on how to do things when projects or issues arise. So whatever currently ails you, I'm here to help you through it.
Yeah, you're a polyethylene expert. You've been doing it long enough, Dan. You can call yourself that now. And Dan works with Alan Ambler, who's also pretty well known throughout the United States and Canada as being an expert in pipe bursting. But David O'Sullivan, you and I met when we were doing our road shows, and you came to one of Jeff Lohr's programs. So welcome to the podcast.
Thank you.
Tell us what you do.
How long do you want to go back? Back in the 90s, mid-90s, in British Columbia, I saw a niche in the market for Trenchless technologies. They were being introduced in British Columbia, pipe bursting. CIPP had come into Canada in the early 80s. It was here in the late 80s in British Columbia, and it had expanded from there, but still fairly niche. But I saw the pipe bursting and the directional drilling. I did a lot of directional drilling with another company called Directional Mining and Drilling.
Okay.
In the 90s. Some big stuff and some weird stuff at the time. And I saw again that that market was expanding and expanding rapidly. So I decided to set my own company up in January 2000, as PW Trenchless Construction. And we generally specialize in pipe bursting and slip lining. We've stayed away from horizontal directional drilling in a big way so far, but we do some smaller horizontal directional drilling.
And are you a citizen of Canada?
Yes. Yep.
So you've emigrated from Ireland.
Oh, in 78.
Right.
I came to Canada in 78. I did my engineering in Ireland, came to Canada in 78, worked as a consultant for 6-7 years, and switched to the dark side of contracting in 86, 87, 86, and ran another construction company for 15, 16 years, and then started my own company in 2000.
Nice. How is the British Columbia market? I see you work in Washington as well.
Mm-hmm.
How is that market for trenchless?
It is evolving. I find, Peter, that I do a lot of teaching and lecturing and lunch and learns and introductions to trenchless, and I find that it's not a very high importance right now in the universities. A lot of the students coming out do not really know very much about trenchless technologies. And thus we can get some questions that your jaws drops on with people from people who have been in engineering for 5, 10, 15 years, and you go, my goodness, what's happened here? And that's my fault, because I'm just not getting out there and educating. That's the problem.
Yeah, you take responsibility for it, right?
I do take responsibility, and thus I'm really push this whole concept of lunch and learns. I would say I probably do 2 to 3 a month of going talking to either consulting engineers or cities, and I've got a presentation that takes about an hour. It introduces all of the different types of trenchless technologies, or as many as I can, both rehabilitation and new construction. And it's not just what we do, it's what lots of different companies do. And I try and get out there as a kind of a neutral party to educate people, because I feel if I educate the communities, it will come back to me and help me eventually, but it'll also help the industry in general. And I'm passionate about trenchless technology. I feel it is a phenomenal method of construction. There are so many things that are leading to it right now. When I started in this in 2000, most cities did not really know what they had in the ground, nor did they care. And when they went in and did repairs, it was repairs as a result of collapse. So it was reactive repairing. Finally, other things have changed in the last 15, 20 years, both US, Canada, New Zealand, France, all over the world. Governments have now started to go in and force municipalities to start looking at their assets and recording their assets. And then what comes out of that is programs to start, examining these assets and doing a stock take, if you want to put it that way. And then what comes out of that is, oh my goodness, this pipe here is, it's in good condition, but it's cracked badly. We need to go in and rehabilitate this thing before it collapses. And that, for us, leads to over 50% of all trenchless technologies. Mm-hmm. The rehabilitation. And then one thing that I started working with in here, British Columbia, back when our premier in British Columbia and Arnold was in California, they both caught on to, and I know it's a bit controversial, but they both caught on to the carbon issue. And we were able to demonstrate the carbon emissions for trenchless technologies are probably 10% of what they are for open cut, because you're just not moving dirt, right? And whatever your position on carbon emissions are, that's one thing. But if you can avoid the disruption of traffic, avoid the disruption of moving dirt around to get at a pipe that's way down in the ground, I mean, that has to benefit all types of society.
All right, for sure. You've got the carbon footprint of construction, right? Yeah. And then you've got the polyethylene pipe, which has its own sustainable argument, which is pretty fantastic. But before we go any deeper, tell us about PW Trenchless. I'm looking at your website right now, and you've got, 60 employees. How many crews do you run?
3 crews. We're running 3. Yeah, 3, say 8 to 10 man crews.
Wow. And I see one of the guys in your photograph is the Dean of Soils is in your photograph. Is he a consultant for you guys?
Yeah, he would be a consultant. Yeah.
Is that Amster?
Yeah, Amster Howard's in the photograph.
I'm on the outskirts of this joke.
Yeah. We had Amster Howard speak at Showcase a couple of years ago. Did a great job. What a fine gentleman he is.
Yeah.
But that leads me, David, to, as an expert, tell us about soils. Soils are overlooked. A lot of utilities don't want to spend money to give you geotech, yet I can't imagine of anything more important except pipe condition to the success of a trenchless job.
Well, it depends on whether we're talking about new construction or rehabilitation. Of course, if I'm rehabilitating the inside of a pipe, in other words, slip lining it or CIPP work, I don't care about the soils. If I'm pipe bursting, I do care about the soils. But one of the issues that I have, though, Peter, is that most consulting engineers or geotech, when they look at soils and they're thinking about doing a soils report for a pipe bursting job, of course, they'll come along, they'll put a pit in 2-3 meters, 6-7 feet, 10 feet off the side of the trench. That's useless. It's not information that we need. In a pipe bursting job, what we need is the information of the soil and the compaction of the soil over the top of the pipe. And actually, I've developed some nice sketches on that, because there's some information on that, but not an awful lot. Louisiana Tech did some stuff. Ray Sterling did work on that. So for the U.S. Corps of Engineers back, I'm guessing 15, 18 years ago. He did the Guides to Pipe Bursting, which is a very, very good document. And he talks about soils, but not in great depth. My theory is that when we pipe burst, that the movement of material is slightly laterally. Because if you think of a pipe burst pipe, the inverts stay the same. Therefore, the spring line of the new pipe, let's say we're going from an 8-inch to a 12-inch, the spring line of the new 12-inch pipe is actually going to be 2 or 3 inches above the spring line of the 8-inch pipe. And then the crown, of course, is 4 inches above. So all of the movement of material is above. And so you've kind of got this teardrop of ground movement that happens above the existing pipe.
Right.
You've got, yeah.
Yeah. So I've always said 80% up, 20% to the side and down, because I have heard of some damage to pipe below the pipe that was being burst.
You can. I mean, we're talking, Peter, in soils. So soils are the most inconsistent item you can get there, especially here on the West Coast, all the way down to California. If I go inside the Rockies into the flat areas of Canada and the US, the soil becomes much more consistent. But out here, it can change 3 times in the length of a pipe run. But generally, it is the most unknown. And if you are, I would say yes. If you are bursting in peat, the expansion will go down. But generally, the existing ground is more compacted than the area above the pipe. Think back 70, 80, 100 years ago when they were putting pipe in the ground. They didn't have any compaction methodologies. So they just dumped material on top of the pipe and left it. Then as they came up to the top of the trench, they would have compacted it with a roller, a steam roller probably at that stage. And so the top is compacted, but that zone above the pipe has compactions of kind of 80, 85% compaction. So that can withstand a fair bit of compaction from pipe bursting. Even modern pipe installation processes, you're not going to hole pack the material just over the top of a new pipe that you put in. You'll come up 3, 4, 5 feet before you start hole packing. So that first lift above the top of the pipe is fairly loose material. And then you get an arching effect of the soil as it goes up and then, goes from there. So that zone that we're depending on, that zone above the top of the pipe, that, 5, 6 feet foot zone above the top of the pipe to take the expansion that we're trying to impart into the soil to allow us to expand and put new pipe in the ground.
Yeah. So for directional drilling specifically, same thing for pipe bursting. I get a lot of questions and people, in the engineering world like to speak in definitives, whereas, that's really not a reality. So a lot of times I say, reach out to your local contractors. Your geotech's great, but the contractors really know what you can and cannot do with those soils. Did you have those conversations? And it kind of, I guess what I'm getting at is, do you assume any of the responsibility and kind of saying, hey, we can't do this, or this is going to be really difficult?
Yeah. Oh yeah. All the time. We'll get people coming to us all the time and asking us, I want to drill this 600 2 foot diameter pipe across the road here. And I'll go, well, for starters, you don't drill a 600 millimeter pipe or 2 foot diameter pipe across the road. You'll pipe ram it or pipe jack it. Number one. Number two, what's under the road? And they'll go, well, we don't know. I said, well, if there's going to be cobbles in there, you're in trouble. Or what I'll often get, Dan, is a railway line. You'll get a railway embankment. And I will go, watch out. Because think back how I would have built a railway embankment. I would have gone in there with raw wood, built a trestle, because I didn't have trucks back in the 1910s, 20s. And I would have just built it as a trestle, and then I would have belly dumped out of the train wagons. So you probably run into wood underneath there.
Wow.
Right? You could have put an old pile system in there. Or any raised ground that's under a highway, you can run into wood stumps, and what a stump is it's like a tire. It's elastic. You hit that with any kind of a percussion system, like a directional drill or a pipe ramming system, you're just going to bounce. You're not going to go anywhere, right? And so you really got to be careful that you don't run into something like wood. Wood is really bad. And then, of course, cobbles and boulders will tend to deflect a directional drill. It'll deflect pipe ramming systems, pipe jacking systems. You got to be aware. And you can say, well, I don't know if there's boulders in there. Well, then be open to the fact that if there are boulders in there, you got to help the contractor.
Yeah, you've got to have an out. You got to have a line item for that. You said you're not going to drill a 600-foot under a road. Why not? Why do you have to pipe jack it or pipe ram it?
Well, Peter, because a lot of people have this concept that there's two types of trenchless technologies. There's directional drilling and there's CIPP. And everything goes into directional drilling if it's new, and everything goes into CIPP if it's rehabilitation. And that's their mindset. So they'll come to us and they'll say, we want to get this 2-foot pipe across a railway line or across a highway, and we want to drill it in. And I'm saying, you don't drill in a pipe that size. You would pipe ram it or pipe jack it. It just doesn't make sense. I mean, the rig you'd need for a 2-foot diameter pipe is an enormous rig, and it just doesn't make sense to do 660 feet or 80 feet, right, with that size rig.
But you could do 600 feet.
Oh, that's right. But you don't have a highway that's 600 feet wide unless you're going to go down to LA and you're going across, a 20-lane highway. Yes, then yes.
I see. Yeah, because we see a lot of 800-foot HDDs, right, Dan?
Oh, yeah, sure you do.
Yeah.
That's probably the sweet spot.
Yeah, exactly.
That makes sense.
Yeah, I will say on just, for the audience listening, the highways you're describing are typically really high load capacities. So a lot of times on transmission projects or, like a 2-lane highway, you're bisecting or something like that. You're typically at least I see more horizontal directional drills because you don't have to go down to quite the burial depths, and it's kind of considered less risk.
Well, are you going across, Dan, or are you going longitudinal?
So if you have like a major highway and then, all like the service roads on the side.
Yeah.
So typically crossing the service roads, I see more drills just because it's, the whole criteria is so different.
Yes. Yeah, no, I totally agree. If you're going that length, I would drill it across. If you're going that length, but if you're going across 4 lanes is typically 80, 100 feet. You would just ram it, pipe jack it.
Okay.
Do you guys get involved in some of that?
No, I would refer that on to other companies.
Okay.
You can't be everything to everybody. You got to specialize in just areas.
Well, you've got a great client list. What are these cities asking you to do? And do you have a lot of competition in the trenchless side of things?
In the lower mainland of British Columbia here, where Vancouver is, there's probably about 15 cities. And in Vancouver Island, there's another 5 or 6. And around the province, there's probably about 30 cities. So we're dealing with all those cities. Now, not all of them use trenchless all the time. Some will use it passionately, and some just haven't started drinking the bathwater yet, Peter. They're still out there as Luddites, and there's nothing we can do about it. We teach them, we talk to them, but they're slow to come to the bathwater.
Yeah, you call them Luddites, and I don't call it bathwater. I call it Kool-Aid. After the old Jim Jones debacle. But you're definitely, people either drink the Kool-Aid or they don't. So these cities, you're primarily, 80% of your business is pipe bursting?
About 50. 50%.
50. And do you do open cut or just with polyethylene or not?
Very little. We would do open cut with conventional, but not very much. Open cut would be probably 20% of our business. Then we would do about 40% slip lining, both with GRP or snap tight or polyethylene, and haven't got into compression fit yet, but we're very close to it. We're talking a lot to Murphy and about using, because I've got all the equipment to do compression fit. And I think we're actually working on a couple of jobs right now to do compression fit up here.
Is it out of its license yet?
Oh, yeah. Yeah.
Okay. So are you using rollers or dies?
Guys.
Okay. I wasn't aware that it was out of its license yet. That's cool. Good for you. All right. So where did you learn about HDPE?
I'm just trying to think back now. It would be back in the early 90s. Early 90s in British Columbia, high-density polyethylene was just starting to come in. Actually, in fish farming is one of the first areas it came in. They were building the floats and the pens with high-density polyethylene pipe and fusing it together and building them that way. And
they still are.
Yeah, that's right. Great product for that. And then for piping as well, especially with any kind of trenchless. When we started with pipe bursting back in the 90s and directional drilling, I mean, all you can use is really all you can use is high-density polyethylene. You know, there are other people who tried to come in using ductile iron, restrained ductile iron, and, you know, I mean, I suppose Underground Solutions with their PVC, fusible PVC is a product as well. But we have really stuck with high-density polyethylene, and we propose, anytime people talk to us, we propose high-density polyethylene where possible.
Now, the problem with HDPE is when you're talking to these entities for the first time, you know, you're teaching them two things at once. You're teaching them trenchless and trenchless with a pipe they don't really know.
Yes.
I mean, you're making the sale more complicated, yet you do it anyway. You know, what are some of your techniques, and how do you get them to yes?
I talk with well, I mean, if they're going to go trenchless, if they've come to the point of view that they're going to use trenchless technologies, then really the only product that we can use is high-density polyethylene. What we do with some of the cities too is, because one of the kickbacks you'll get from a city is that if I'm putting in a water main and it's high-density polyethylene, they'll come back and say, well, I can't do as connections. How do I do a connection? And we actually provide that service. So with the number of cities who have high-density polyethylene water mains, they will use us to go in and do connections, even though we've even tried to teach their staff to do them. I now see some of the mechanical companies or mechanical connection companies are coming in right now and providing mechanical connections to go off a high-density polyethylene, even though I would prefer to see fused-on connections, but the mechanical ones seem to be fairly good as well and reliable. So, I mean, if it's a mechanical, then anybody can do it again. It's just the same as any mechanical connection, you know, saddle you've got on a ductile pipe or a PVC pipe. So, I mean, getting over that is the big thing. The other thing is, you know, we're in a seismic zone in British Columbia, so being able to sell to these cities that if you use high-density polyethylene, it's much more seismically in tune with the ground than is, say, a pushed-together C900 or ductile iron pipe. One of the big things we're doing right now with the City of Vancouver is the City of Vancouver and Metro Vancouver. They're both two big entities. They have a large ductile pipe that they installed in downtown Vancouver in 1998, 99, and they have found it's already corroded in 25 years. And we're trying to convert the City of Vancouver over to using high-density polyethylene. The funny thing is we have the consultants are on our side and saying they've got to come over and start using high-density polyethylene. But they've historically used only ductile. But we're shocked to see the bottom of the pipe, the invert of the pipe, it looks like Swiss cheese in 25 years.
What diameter?
900, so that'd be 36 inch.
Goodness, how embarrassing.
Yeah, it is. Because in fairness to ductile iron pipe, it's a great product if it's used in the proper location, and it stands to be rehabilitated numerous times. You know, you can go in, clean it, and spray on liners on there, on the inside of that pipe, and it works very well that way. And it's rigid. But it does have issues, and it when used in the right place, it can be good, but not when it's not used in the right place.
Why not use a pipe that works in all situations?
Because it's new, Peter.
Well, anyway, back to my question. So you're teaching them two things at once, right? They're used to a bell and spigot system.
Yeah.
And you're going to teach them a trenchless technology and a new pipe that they're not totally comfortable with. You know, we used to say that, and Dan keeps trying to get me to not say that. I mean, we have, what, Dan, 20% of the market, so it's a lot more than we used to have, but we're still not the first pipe people go to. That's PVC. You know, that's their first feel-good pipe. PVC was a good pipe. It's just not as good as polyethylene. So what are some of the reasons, other than they're not used to it, that they're telling you that they don't want to go with HDPE?
I would think, Peter, that one of the negatives of HDPE is an open cut method of construction. If I'm down 10, 12 feet, I'm using a shoring cage. I dig 15, 18, 20 feet the length of my shoring cage. I want to put a piece of pipe in. Whereas high density polyethylene is a continuously fused pipe. Yet, you know, to push a spigot into a bell is easier than fusing a pipe in the trench. Now, if you want to, high density polyethylene lends itself much more aptly to trenchless methodologies, where you're assembling the whole pipe on the surface, on the top, and then you're pulling it in either through pipe bursting or directional drilling or slip lining it. It is perfect for that process. You can use electrofusion couplings, you can fuse in the trench, but it's a little bit more work. And I think that's their mindset. That's what you've got to go up against. So it just got to overcome that. Again, if you're shallow, it doesn't matter. You're shallow, 4 feet deep, you just keep on digging the trench and then just slip the whole thing in and backfill the whole thing at one shot.
Yes. Okay. So you're saying it's a harder sell when it's a deeper installation.
Correct.
Profile.
And it's not as that because high density polyethylene is not as rigid as, say, PVC, and certainly not as rigid as ductile. You have a much thicker wall to get the same DRs or the same strength as, say, PVC and or ductile iron. But, you know, no product is perfect. Every product has got its limitations, and you got to play to your strengths. And the strength of high density polyethylene is one pipe from end to end, from fitting to fitting, or from manhole to manhole. It's just one pipe, no joints, no leaks. It is flexible. It is, even if you have some movement from seismic, it won't pull apart. So it's got a lot of benefits like that.
Yeah, for sure. What's the project that you worked on with polyethylene that you're most proud of?
We did a pipe burst over about 4 years with one of the cities here in British Columbia. Say 16 to 19. So 2016, 2019. And it was a city that is in the east side of the lower mainland of British Columbia, and they're undergoing enormous growth right now. They had a trunk sewer line which was 15-inch diameter. PVC had been installed in the 70s, 80s, and they were finding that they just had enormous growth happening upstream of that, and they had to upsize it. And that sewer line had been put in at about 0.05% grade, so very, very flat. And so we ended up pipe bursting it. So we pipe bursted from 15-inch to 36-inch.
Whoa. Yeah.
That job got job of the year for rehabilitation at the no dig back in the one in Palm Springs, I believe. But that's a big upsize. That's a 6 times upsize.
What was the burial depth on that?
3, 4 meters, 5 meters.
Wow, so pretty deep.
Yeah.
That's exciting. So did you test it first? Did you test a 100-foot run to see if you could do it, or did you just do it and you oversized it? And did you rent the equipment, or did you buy it? What'd you do?
The first bursts we did were probably 15-inch to 22-inch. And then as we were going downstream on this job, we were getting bigger and bigger on the sizes. The last one was the 15-inch to 36-inch. So as we were going each year, because it was a 3 or 4 year contract, as each year came along, we were getting bigger and bigger and upsizing, and we could see what was happening. And I have to say, halfway through, probably 2/3 of the way through, the first 2/3 of the way, I rented it. So I made Chris and TT Technology rich on rentals. And then I turned around and bought the machine from him. So he got the rentals for 2 or 3 years, and then he was able to sell it to us. So we bought a 2500. In fact, we bought one 2500 machine, and Murphy has the other 2500 in Florida. So those are the two biggest bursting machines, except for the ones now that come in from Sweden, which is a 400-ton machine.
So it's a 250-ton machine.
That's right.
Can that machine burst through valves?
Depends on the valve. If the valve is cast iron valve, I'd say yes. One of the problems, Peter, in bursting an anomaly in a pipe that is not of the same structural strength as the rest of the pipe is not so much the bursting of the product. It is the ability of the downstream pipe to hold that product in place while you're trying to burst it. If you understand what I'm trying to say, is that if I take a piece of paper and I try and cut it with my hand, if the paper moves, I can't cut it, right? So, and what we do in bursting is that the existing pipe, the pipe we haven't burst yet, is they put into longitudinal compression while it holds the pipe that's being burst in place. But if the compressive forces of that downstream pipe are such that they're not strong enough to hold the tool as it's coming down to burst the valve that you're talking about, then what will happen is the pipe downstream of that will collapse and just accordion on you. And that's invariably what happens in these things when you don't end up bursting a valve or a roll bar coupling or a repair piece of pipe and stuff like that.
Good explanation. So what is your attitude about a segment that has 14 unknown high-max band clamps on it? Do you just assume they're there and put a nice splitter on there or a cutter head? What's your strategy?
We've changed strategies. I was doing that, going in and bulling my way through it, trying to bull my way through it. Now what I do is I will prepare it, isolate that 100-meter section, 400-foot section, put a camera through, see if I can pick up some stuff ahead of time, or go back to records. What we've also done is we've gone to, if we get a project with the city, which we just did one in the interior of British Columbia about a year and a half ago, we did about 2 or 3 kilometers of steel pipe that was put in the late 40s. There was a lot of excess pipe made during the Second World War. It was very thin walled pipe. It was only about 1/8 of an inch thick. It was a spiral wound steel pipe. It became surplus after that. A lot of cities bought it up and used it for water mains. So longitudinally, it's very thin, but for, it's more than suffices for 6-inch or an 8-inch water main. And what we found on that particular project was that if you weren't careful and you tried to go through, say, a roll bar coupling, that you would accordion the pipe. And I have loads of pictures of accordion pipe, which is a real mess, because it just accordions on you then, and you build up this big mess, and you're not cutting anymore. You're just pulling this massive pipe through the ground, and your loads are going up and up and up all the time. So it helps to know where these couplings are. And what we have found is that a lot of the knowledge is there. It may not be in the as-built drawings, and so it may not be in the city hall. But I guarantee if you go and talk to the superintendent or an old retired superintendent, take him out for a couple of beers, you could probably find a lot of where those repairs were over the years. And again, then then we'll start looking for them. And then what you'll do then, Peter, is you'll tend to change your job, and you might make some runs shorter or some runs longer and try to get a pit where that repair was or is.
Is some of the advice that Dan and I use, David, is, you don't necessarily want to be proud you did a 1,200-foot run. Yes. You want to be proud that you got through a 500-foot run so that you were ready to do another one the next day. Is that good advice?
Yes, you've got it. Exactly. Because you lose face you lose credibility. Your staff gets annoyed. Your crews get annoyed when they get stuck like that. And it is much easier just to get in there and do a 500-foot run day after day. It almost becomes a bit boring, but that's okay. Boring is good.
Yeah. So you have, if you get like 6 band clamps caught up and you're pulling, and you stop, that's an unplanned excavation.
Yes, it is.
And I assume you have a line item for that on your bids.
Sometimes you do, sometimes you don't.
So that could be a change order or not?
You can get change orders for them. It depends on the contract and depends on the how the administrator is dealing with the contract. Sometimes if I can plan where they are, I'll try and dig it up there. In other words, I'll know if there's a fire hydrant, there's a fitting here. I will know if there's a valve here, there's a fitting here. I've had to dig a pit there. Sometimes you get valves that have just been abandoned and buried. You don't know where those are. But a valve on its own is probably not bad. A valve on its own will snap. Generally, you go through it. It's what we really get caught on is row bar couplings, because in a row bar coupling, you think about it, you've got a ring, a barrel of the coupling, and then a ring again. And then you've got probably a piece of C900, 3 or 4 meters, 10 feet of it, and then you got the same thing again. And that is very hard to cut through. That can catch up on you. And once one ring or one section of barrel from a row bar catches on you, then the whole thing is just going to become an accordion in front of you.
All right, one final question before we move into slip lining. When you're, let's say you have the audience of city staff, and what's the price spread? What's the VIG between open cut that they're used to and a pipe bursting renovation? How much less expensive is pipe bursting?
Good question. 3 months ago, November this year, the city of Surrey, where we're located right now, a city of about 500,000 people, put out a contract for about $10 million worth of open cut sewer works. And we decided just to be a disturber, to go in and put an alternate bid in. Now, it was an alternate bid. It wasn't going to be accepted, but it was going to send a big message across everybody's bow. They had 7 bids. 6 bids went from 10.1 to about 11.7. And PW Trenchless was in there at 8,100,000.
And so you basically just bid that on a lineal foot basis?
Yep. And they didn't accept it because there were some engineering issues, but we did it as a waste bid to demonstrate the cost effectiveness of Trenchless technology. There were some engineering issues because some of the lines, they were lowering it down by 4 or 6 inches, and because they could, and of course you can't lower it in pipe bursting. But it sent a major message across the bow to this city that, oh my goodness, you better watch out and start using Trenchless technology where you can. The problem, though, Peter, is that because there's not that many pipe bursting contractors out there, if they put it out as pipe bursting, then they know they're going to get maybe 2 bids. Mm-hmm. If they put it out as open cut, they'll get 7 or 8 bids. And as purchasing departments, they like to get 7 or 8 bids with a spread of, say, 10-15% from low to high. Because then they can go to council and it's all above board and everybody's happy. Even if they know it's $10 million and above, if they go in with 1 bid, it's $2 million, that's $8 million. You're always going to get some councillors going to say, how do we know that that's best value for the city? And they can't know because there's only one contractor. So what we have done here with a number of cities is we've asked them to go up both ways. So in the tender documents have the section A, which might be paving and gravel imports and stuff like that. They have that common. And then go B, which is pipe bursting in one side, or C, which is open cut. And then add the 2 together at the end. And so you can bid A, you have to bid A, you have to bid D, but you can either bid section B or section C.
Yeah, so you end up with half open cut, half bursting. When you have to change the elevation, you go open cut.
You do that. Yeah. Or you might get you get the whole contract would be pipe bursting, And what we found in the 2 or 3 cities that have done that, consistently they were getting 20% savings by using pipe bursting versus open cut.
20%. Okay.
Yeah.
And
now,
are you working primarily in potable water or sewer or both?
Mainly sewer. Very little potable water. We find in British Columbia that most of the city crews, they get paid the same rate of pay whether they do potable water or sewer work. So they like to do potable water and then let the sewers for the contractors. So a lot of them, and a lot of the potable water has been replaced at this point. We had a lot of asbestos cement pipe in British Columbia. A lot of that has been replaced. Where we're now looking at is ductile iron pipe, and the ductile isn't undersized. It's of sufficient capacity, so just rehabilitate the inside of it using polyureas and that type of thing on the inside of the ductile iron pipe.
Mm-hmm.
We haven't got into, that's where I would like to get into the compression fit though. I think there's a good benefit for compression fit in there on the trunk lines. We have done some slip lining on some bigger trunk lines for water, 26-inch into a 36-inch pipe.
Cool. So tell me about your slip lining work. What is it? Water? Is it sewer? Is it transmission? What kind of projects are these?
So the province of British Columbia is 1850s when it really started. Some of the sewer work at the time would have been brick sewer lines, pipe arch, that kind of stuff, especially on the lower end of Vancouver Island. And what they have found there is their pipes are starting to fail. They're 150 years old, 160 years old. We did one particular one in 2017. It was under a graveyard, which had a lot of the dignitaries of the province from the early parts, the 1870s right up. And they were not going to exhume bodies to redo this sewer line underneath. So we went in, we had one access point about the size of a table, a boardroom table, and that was it. And we had to do 300 meters, so 600 feet both ways of a pipe arch. It was about 5 feet wide, 3 feet high. It had 14 bends in it, horizontal bends, and it had 3 vertical drops in it. It was beautifully done inside. I mean, when you went into those drops were 3-4 feet high. They had a granite step on top and a granite receiving step on the bottom where the water would go over the granite at the top so it didn't wear the brick and then hit the granite on the bottom. I'd take all those out and make ramps there, but we were able to go in and slip line that. That was not, of course, with high-density polyethylene. That was with GRP product. So those are non-circular pipes. You have to have a different type of pipe. So GRP. On circular stuff, we use Snap Tight, which is a high-density polyethylene product. We culverts anything up to 6-7 feet in diameter. After that, they tend to go towards pipe arches once they go above 6 or 7 feet because you're getting to be so big. But that's, and again, if you're going to a pipe arch, you're back into a particular pipe. Either you're going to slip line it with high density not with high density, with either GRP or with corrugated steel. Anything less than 6 feet, they'll tend to use circular. So anything from 12-inch up all the way up, using either high density polyethylene fused pipe or Snap Tight.
Nice. So what's on the horizon in British Columbia and Washington State for you and Trenchless?
Well, as I said to my staff last week at our Christmas party, just taking the reports from British Columbia that are reported back into the province by the cities, and we explained this at the start, we're talking about asset management and so on. If you look at the reports that have gone into the province from British Columbia, just the lower mainland, greater Vancouver area, there's about $30 billion worth of sewer, sanitary, storm, and water mains in the lower mainland. If you assume 1% of that needs to be replaced a year, which is a 100-year lifespan, that's $300 million a year. I don't think I have to worry about my market.
Yeah, well, you got to assume they're going to pay attention to that. I mean, are they? The average cycle time in the United States is 274 years. So, I mean, they're not paying attention to those numbers. Maybe they
True.
are in the provinces.
No, they're not. They're not. Agreed. They're not doing it here too. I mean, but if you look at asbestos cement pipe, that does not last 100 years. Your brick will last 100 years. In one of the presentations that I do, Peter, I have some of the aqueducts that the Romans put in. I was in Spain last year at Segorna, and the aqueduct there, they only stopped using it in 1920s, and that was put in 50 AD.
Holy smokes.
1900 years of use of a water supply to that city.
That's extraordinary.
Isn't it amazing? So we hope not going to be that good at making stuff nowadays.
Wow, for sure.
So
tell me about the value that a guy like Jeff Lohr at ISCO AH has brought to your organization. I mean, what is his expertise? How has it helped?
It's funny because Jeff and I are talking. We're doing a lunch and learn on the 26th.
Oh, he just called me 45 minutes ago. I didn't know it was with you, Dave, but that's very funny.
Yes. Yeah. Jeff and I are doing a presentation. So I started with a marketing company, but 2 years ago for PW Trenchless to help me market PW and Trenchless Technologies in general. And one of the things that came out of that is organizing these lunch and learns. We hire a hotel room, invite anybody from municipalities or consulting engineers, limit to about 100 people. And I will talk and bring in people like Jeff or other people like that, and just do a talk on Trenchless Technology and the products available for use in Trenchless Technology. And it just happens that Jeff and I are doing a presentation in 2 weeks from now. And so I want him to talk about high-density polyethylene, the benefits of the pipe, of the product, of its ability, of its fusion, of the fact that you've got one pipe. I will talk about the flexibility of it. I'll talk a little bit about the elasticity of high-density polyethylene, that I can take it and I can put it through a die, and I can take it down in diameter from, say, a 24-inch to 22-inch, put it into an existing pipe and let it relax and come back again. Or I can take it and I can fold it into a U, band it, and put it into an existing pipe and pop it up again. I can't do that with any other kind of pipe. I mean, that's some of the fantastic abilities of high-density polyethylene. And then if you think of how flexible that is, because when you do that, you're not taking it so that it fails plastically. Because once you fail plastically, you've cracked the pipe and you've yielded. Right. As long as it's in the elastic limits of the pipe, it's fine. And it has an enormous ability to elastically deform and not get to its plastic limits. And no other pipe has got that. And so we use that to help us. And then when you start to think, those are two obvious ones. When you start thinking of a high-density polyethylene pipe being put in the pipe burst, it's snaking and being pushed around and belted around and hit by excavators and pushed down into the pit and then snaked in and bursting apart the existing PVC pipe. I mean, you can't really do that with any other kind of product. So it's very flexible, and it really is. It's an ideal product for Trenchless Technologies, drilling and our pipe bursting, and it's very movable. Steel is probably 4 times more rigid. PVC, again, you've got a much longer entrance fit in PVC, and you certainly can't belt PVC around, and you don't want to belt around steel because you'll destroy the coatings. When I say pushing it around with an excavator, pushing it around with a backhoe, I mean you've got this 10% gouge that you can have in high density polyethylene. You're still within spec.
Yeah, crazy. All right, what? I know Dan's got a question, but I want to ask you one more here before we wrap up. And to our audience, thank you for hanging out with us here. What advice? You wear 2 hats. You're an engineer and a contractor. What advice do you have for municipal governments when they're contemplating rehab? What advice do you have? You've talked to a lot of them. What one thing would you want them to know?
I can give you a long answer, Peter, if you want to. Something I'm working on right now with an organization called QEEC in Canada, which is it's a Canadian utilities organization. I feel ethically we owe it to society to look at rehabilitation rather than abandoning and putting in new. You've got a hole in the ground. There's an existing pipe in there. That pipe may not be functionally able to handle the water. In other words, it's got leaks in it. It may be too small, so it functionally is too small, or maybe it's collapsing, right? In that it's got cracks and lateral cracks in there. But you've got a hole in the ground still. I feel ethically we owe it to society to spend our money judiciously and rehabilitate as much as possible. I think rehabilitation should be the first answer to what we're doing, not abandon, throw it away, and just dig up the road and dig everything up and cause all kinds of mayhem and open cutting everywhere.
That's really good advice. My goodness. I think that's going to be our teaser. Dan, you got one final question.
Yeah, I like that. I like that answer and question a lot. I want you to play a game with me, David. It's the same game me and Peter play in the car between road shows when we're bored. And it's called 100 Lives. So if you had 100 lives and you get to, pick what to do in each life. If you're a 30-year-old contractor starting all over again, it's 2025. You're jumping into this pipe world. What's the one method you're focusing on and why? You can only do one installation method.
Oh my goodness. Pipe bursting has been good to me, has been very good to me in the last 25, 30 years. I would still stick with pipe bursting, and that maybe because few of the contractors have come into play in my sandbox, if you like. There's a number of directional drilling contractors, but there's not that many pipe bursting contractors. So I would stick to pipe bursting. I also really like slip lining. I think slip lining is a very, very effective way of rehabilitation, especially under highways and railways. One of the issues we have is that our highways department aren't very proactive on their culverts yet, but they will get there. So those two have been very good. I don't think I would change an awful lot on what I've done in the last 25 or 30 years.
On those slip lines, do you grout the annulus just at the ends or the whole thing?
The whole thing. We'll grout the whole annulus.
Interesting.
And depending on the diameters, we either grout it from inside or we'll grout from the ends.
Do you find that it often requires a larger angular space in order to, shorter pulls in order to pump the entire angular space?
Nope, we use cellular grout. 2 or 3 MPa cellular grout here, and it'll flow from here to Vancouver, Seattle if you want to.
Nice.
Exaggerating, obviously, but
that's good to hear.
Yeah, you can essentially go, it's almost like a straight liquid, so you could probably do 200 feet and have 5-10% drop in the elevation. That's it.
Are you doing that because that's spec'd out, or you just think that's the best practice for a 100-year further install?
We recommend that when people come to us and they ask us to do a slip line, invariably if it's the highways department here, they'll come to us and it's a design build essentially.
Wow, okay.
Right? And so they don't really know what to do. And sometimes we'll get some consultants who would want a product that's 10 MPa or which would be 10, 12 PSI, and we'll try and talk them down to the 2 or 3 PSI. If they want the 10, one of the problems if you get into the higher strengths, you've got a higher angle of repose in the material.
Mm-hmm.
It doesn't flow as well. So yes, you can have a higher strength material, but the problem is that then you're going to get voids in there. There's a compromise between the higher strength material, which is a higher angle of repose, and a lower strength 2 or 3 MPa or 2 or 3 PSI material, which has got an angle of repose of 0, just flat.
Right. So what's the argument for full grout? You're not worried about the polyethylene?
No, I don't know, Peter. Good question. It is a North American issue. Europeans don't grout that much. They don't grout as much on the full grout. They tend to leave the annulus in there. The only argument you would have is that if you're trying to create a composite product, in other words, if I go back to what I said to you a few seconds ago, the structure, the existing, so I've got my existing ductile iron pipe, It's got holes in it, but the structure of the ductile iron pipe is still great. So I'm going to slip line a high density polyethylene pipe inside there. But I want to use the structure of the ductile, and I want to use the vessel capacity or the ability to hold water of the high density polyethylene pipe. Therefore, I have to do a composite product. So how do I join the two together? Well, the way to join the two together is to grout the annulus. So therefore, I'm locking the high density polyethylene to the ductile using this circular, the hoop strength of the ductile, and the to hold the ground.
That's what you're saying. Yeah, same thing you do with an open trench. You're saying you get that soil reaction, but in your case, it's from the structural cavity and the grout pushing off of it. Yeah, that does make sense. We typically say the first and last 20 feet, just because, for cost savings purposes. But if you're doing a design build, I see merit in that as well.
Mm-hmm. These would be under highways as well. These are these are not water mains. These are culverts, highway.
Yeah, so we're worried about settlement. We're worried about differential settlement.
That's right.
Yeah, if there were to be leaking, there wouldn't be any type of wasting. Yeah, that makes a whole lot of sense.
Right. Well, guys, great conversation. I think we need to wrap here. David O'Sullivan, fantastic. Great to get to know you better. Congratulations on your career in making PW Trenchless a force in British Columbia and Washington State. You should be so proud.
Thank you, sir. Thank you, Peter.
All right, with that, Dan Landy, let's make this a wrap. And thank you to our audience for listening to another edition of the Poly Podcast, where we come to you every month with another expert from the industry. So with that, we'll say goodbye.